Algebra 1, Day 11. Today we're going to be talking about evaluating functions. So, what exactly does that mean? Well, sometimes whenever we want to make a graph, we want to draw a line, a curve, anything like that, they have a specific formula. And so the way that we find out what that formula translates to onto a graph is we plug in an x value and we get out a y value. Some people refer to this as evaluating functions. So, first of all, let's be clear about what exactly people refer to functions as. This is not the same thing as it passes the vertical line test, okay? So, first thing, I can have a line, and its equation may look like that. I can also have an equation that looks like this. There's lots of different ways to write this. Now, because we're referring to them as functions, sometimes you might have multiple equations you're working with. So especially in something like heavy scientific research, things like that, you might have 10, 15, 20 different equations that you're dealing with. So you don't want to call all of them y, right? So sometimes you may want to name it something else. Typically, you'll see f of x, and then you'll see whatever the equation is. This means this is the name of my equation. Its name is f. This tells me what variable is my independent variable. What number am I plugging in to find out what the value of the equation is? You can also name it all kinds of other names, g of x, h of x, j of x, all different types, okay? So let's go ahead and get started on our notes for day 11. So when we evaluate functions, we substitute. And just like a substitute teacher, what that means is we're just exchanging something. We plug in a given value, which is our x value usually. Sometimes it's an independent variable, into a function, and then we simplify. Now, a lot of times people will refer to simplification as PEMDAS. This is something that I did not learn in school, but it tells you what order you're supposed to do things. So, just like I always say, anytime we're dealing with any kind of equation and there's some kind of parentheses, I just don't want to deal with it. So that's always my first thing. So, this stands for parenthesis, exponents, multiplication, division, addition, subtraction. And this is the order you always do it in. First I deal with my parentheses, then I deal with any exponents, multiplication, division, addition, subtraction. Every single time, okay? So let's go ahead and take a look at this. So for this particular function, f, they've defined it as -4 multiplied times parentheses 3 minus 7x. Okay, so as you notice, here, instead of writing an x, they wrote a -2. What that means is x equals -2. Please tell me what f is equal to at x equals -2. So that way we can find the point that it would exist on the graph. I want you to also be cognizant of the fact that f of x, g of x, h of x, j of x, anything that they name them, that's just a fancy name for y. Same exact thing. So these guys, the values that we're going to be getting, these f of -2, f of -6, these are going to be my range. Okay, so f of -2. The way that I go about doing this is I rewrite everything I see, and anywhere I see an x, I change it to a -2. Noticing here that I put that -2 inside of a parentheses. And the reason why I did that is because I wanted to make sure that I didn't accidentally think it was 3 minus 7 minus 2. Okay? So now let's go ahead and deal with that. So I see here that I have a bunch of parentheses. Well, I always deal with whoever's on the inside first. So I go inside all the way out. Let's go ahead and distribute here. Okay, now I'm going to go ahead and still deal with whatever's inside of the parentheses. So what this means is that at the point x equals -2, f is going to be equal to -68. Okay, let's try the next one. Remember, all I'm doing is changing the x to whatever number they write inside the parentheses and then simplifying. So f of -6 is equal to -4 times 3 minus 7 multiplied times -6. I'm going to do this first parentheses. Now I'm going to go ahead and get rid of the second one. And I end up with -180. Okay, pretty simple. I feel like I have a hang on this. So now let's go ahead and do the next one. Now notice, I still went ahead and just put that 6 in parentheses. Why? Just to let me know that I plugged in my x value already. All right, let's do that one. All right, so I ended up with 3 different values. If I wanted to put these in a table, this is kind of a side note, just so you can kind of get a better view of what it is. Typically, you'll see something like this. Well, they'll say, oh, x is equal to -2. F of x or y is equal to -68, -6, -180, +6, +156. Noticing that these guys are all paired up to make points, okay? So let's take a look at the next one. So here they said g of x is equal to 3x squared minus 5x plus 7. So first thing I want to do here, I want to plug in my x equals 0. So 3 times 0 squared minus 5 times 0 plus 7. Okay, so good thing about this one, they made it super simple. So my answer for the first one is 7. So if I wanted to put that in a table, that would be my first point. Okay. Now, let's do the next one. 3 -5 squared minus 5 times -5 plus 7. All right. So sometimes this can be a little bit difficult to walk through going side by side by side, and I understand that. Usually I'd be working this way like I normally write, but just wanted to let you know that it's easier to head down, but I'm just writing it the way this is set up. Okay, so 3 -5 squared. That means take 2 -5s and multiply them together. So I'm going to multiply -5 times -5, that's 25. -5 times -5 again, minus 25. Positive 25 plus 7. Okay, so I end up with 107. All right, so this one is -5, 107. Big values. Okay, next one, 5. 3 times 5 squared minus 5 times 5 plus 7. So 5 times 5 is 25 times 3, 75, minus 25 plus 7, 57. 5, 57. Okay, so the way that I would also write this is if I had gone straight down in this direction, eventually I would have ended up with an answer that looks like this. G of 5 equals 57. This is exactly like saying y equals 57. This is the particular y value for G. okay? So now, all that's nice and dandy, but let's talk about how we deal with this whenever it comes to real world problems, okay? So, first of all, my domain is obviously my independent variable, represented by x, and also referred to as my input. My range is my dependent variable, which is represented by y, and the output. So, now here's a weird question for you. Can we have half a person, half a shirt, purchase half a ticket? No. Therefore, we have to use set notation. What is that? Discrete. These guys are discrete. So anytime you hear somebody talking about people, t-shirt, anything that you know you can't say I have 2.5987 blah, 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 blah of, that means that it has to be discrete. Because I can't say, oh, we have 3.5 people. That doesn't exist. It's either 3 or 4. It's one or the other, okay? So these would be discrete, okay? So let's take a look at this. The total cost in dollars to buy a concert ticket online is found by this function, where X is the number of tickets. There are at least 5 tickets and no more than 10. Okay, so first of all, what is my independent variable? It's X, also known as my number of tickets. What's my dependent variable? Always Y, which is also the price or cost. What is the function that represents the situation? Well, they gave me an equation, pretty straightforward. Okay, so we got that. What is the domain? What is the range? Okay, domain is X, range is Y. Now this is where you really have to think about it because this may not be clear in the first place, okay? So there are at least 5 tickets, meaning he can have 5, but not more than 10. So he can have 10, but he cannot have 11. So that means my domain can be 5, 6, 7, 8, 9, 10. Now, think about it like this. I still can't say I purchased 5.5 tickets. Therefore, I cannot write that number as an X for my domain. I'm either buying 5 or 6. Okay, now they're asking me what is the range. Well, range is my Y's, but they didn't list them. They didn't tell me anything about it. What in the world? Well, no need to worry. Instead, all I'm going to do is I'm going to plug in each one of these, just like we did earlier. So I would do Y of 5 equals 59.75 times 5 plus 26.5, and then simplify blah, 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 blah. Okay, that's a lot of work going on. So let's make this a little bit easier. Let's use our calculator. So I'm going to go ahead and get over to my calculator here. And I'm going to go ahead and plug in this equation. First thing I'm going to do is I'm going to hit this Y equals button. It's going to bring up this. This is where I can type in my equation. So 59.75 times X, and I'm going to use this button, okay, not anything down here, always this button for a variable, plus 26.50. Enter. All right. So this is a linear equation. Y equals mx plus b. Linear. So if I graph that, it's going to take a second. All right. I'm going to go ahead and zoom. Let's see. Fit. There we go. So I'm going to zoom fit. Noticing it's a line here. Mostly straight. I guess my calculator screen's not all that good. But what I'm going to do is I'm going to hit second, blue button, and I'm going to look for the word table. Okay, so now I have a table of values. And like magic, for every x value, there's an associated y value. So from here all the way down is everything we need. If I purchase 5 tickets, the price is $325.25. If I get 10, $624. So I'm going to go ahead and I'm going to write that down. So my values for this are 325.25, 385, 444.75, 504.5, 564.25, and 624. That was really simple and easy. So anytime you're evaluating a function and you want to know, hey, is this the correct answer? Did I evaluate this appropriately? I can put in my equation y equals, hit second table, and take a look at it. Now, if there's some issue where these are not the numbers you wanted to plug in, because I can scroll up and down, but it usually is set to whole numbers, I can instead go ahead and do plus, and this will tell me how to change my variable. So if I wanted 0.5, 0.25, tens, fives, whatever, so I'll put in 5, and look, whatever number I was hovering on, it started from there and added 5 every time, okay? So I'm going to reset it back to my normal. All right, so let's go ahead and go back to this. So again, another example. So for this one, the total cost in dollars to buy shoes for the players on a soccer team can be found using this function, noticing they didn't call it X and Y. Okay, where S is the number of pairs of shoes bought, and if there are at least 11 players on the soccer team, but not more than 16, what is the domain for this situation? Now, that's a lot going on. So first thing I want to do is I want to go ahead and go through and just answer bit by bit. First thing, what is the independent variable? Number of shoes, S. What is my dependent variable? My cost, also known as letter C. What is the function that represents the situation? C equals 135.75, S plus 9.50. What is the domain? So the number of shoes. Okay, so I look at it, said at least 11 players. 11, no more than 16. 12, 13, 14, 15, 16. Okay. So now let's go ahead and look at the next part. What is the range? I'm going to go ahead and just use my calculator again this time. So I'm going to go back to y equals. I'm going to clear all this out. All right, got that. And now I'm going to go ahead and type in my equation. Okay, now I'm going to go ahead and look at my table. And I'm going to look for 11. So there it is, and there are my ranges associated with it. So that would be 1502.8, 1638.5, 1774.3, 1910, 2045.80, and 2181.50. All right. So another thing that I want you guys to notice, and this is something that most people do not recognize or see, is that in between each one of these, there's a very interesting pattern. It's always adding for the y values, and this only applies for linear equations, for nothing else. There's a pattern in between each one of these. So I'm going to go back to my equation. So the way that linear equations work is they start with this amount. we're going to get charged the $9.50 no matter what. And for each shoe, we're getting charged $135.75. So if I go back at 0, it should say 9.5, and it does. And then for every shoe I get, it should go up by 137.75. And look at that, it does. So that means, for example, if I didn't have a calculator and I went ahead and I plugged in my S value for 11 and I got this 1502.8 and I wanted to go ahead and get 12, 13, 14, 15, 16, I don't necessarily have to plug them all in again. I can just keep adding 135.75 every time. All right. So I think we feel pretty good about that. I want you guys to go ahead and do these example questions for next time, and I will see you next time.